first example I want to focus on is from central Iowa, dating back to later on Friday the 13th into the early morning hours on Saturday the 14th. So we had a storm system moving up from the southwest, and it was bringing in precipitation, but there was warm air overriding the cold air at the surface, allowing precipitation to fall as rain, but then to freeze on contact. So looking at the forecast from WX Horizon for the Des Moines area, we could see everything was good up until the later evening hours on Friday the 13th, and then all of a sudden the grip really drops off. Now I don't have the precipitation tab up here, but it would have showed a precipitation intensity increasing in the form of rainfall, because even though temperatures, you can see here, road and surface temperatures were well below freezing, probably in the mid-20s at this point, it knew that it was going to fall in the form of rain rather than snow. And that's what you can see here on this projection is the ice accumulation on the roadways. So we're not expecting, or it wasn't expecting, any snowfall accumulation on the roadways with this event because no snow was expected, but it was expecting ice accumulating on the roadway and grip, the friction on the surface of the road, really to drop off to cause some hazardous conditions. Then as we got into the morning hours on Saturday, those pavement and air temperatures started to increase and eventually went above freezing, where you can see that red, which is the ice, transition over to just wet pavement, and the grip feature and grip variable increasing at that point, saying that the road conditions are improving. We also have proof that this happened. Not only do we have the radar images, but we have images from Twitter, this from Chicago and Midwest Storm Chasers, showing the ice accumulation on an elevated weather station, which would be a colder surface. And even here from the National Weather Service in Des Moines, showing the glaze of ice on the blacktop or the pavement, and then showing poor road conditions across central Iowa during the height of the event. So the second example I want to show you is an interesting one as well. It's from central New Hampshire, really in the White Mountains area. So it was tough to pick this up on radar because this area is kind of in a radar dead zone where it's difficult to pick up on high resolution precipitation. But you could see some spotty shower, snow shower, rain shower mixed activity here. And this actually caused some pretty decent or pretty significant issues on the roadways due to some freezing rain. So if we look at that, we could see in the Plymouth area, even over into Lebanon, there were some problems on the roadways. When looking at the forecast from WX Horizon, you could see the radar here, again, spotty, some type of precip or moisture in the area. But with the forecast on WX Horizon, it was showing the anticipation for ice on the roadway. And this is in the Waterville Valley area. So showing the anticipation for ice on the roadway, showing the grip really dropping off, which basically, is conducive to hazardous conditions on the roads, very slippery roadways. And surface temperatures were right around freezing at this time, or estimated to be right around freezing. Air temperatures were actually a little bit elevated, a little bit closer to 33, 34. So you don't need very cold air temperatures for freezing rain to occur, or for freezing rain to cause issues on colder surfaces or on the roadways themselves. So just to give you all a sense of how this worked within WX Horizon, it doesn't just predict snow events, but it also predicts those headaches of freezing rain events too, so that you can be prepared ahead of time to make sure you know when it's going to happen, the severity of the event, and the resources that you need to deploy based on the expected outcomes of WX Horizon.